Hello guys, in today's video we will learn about problems with traditional WAN. Why do we have concept of SD-WAN and how SD-WAN solve those problems which we having with traditional WANs. So before that I want to walk through some introductions. Okay, so to understand why SD-WAN exists, we need to understand how enterprise WANs worked before SD-WAN. So what was happening before SD-WAN? Companies connected their branch offices using traditional WAN, which primarily relied on the MPLS. MPLS means multi-protocol level switching. So the enterprise network looked like this. We have branch A, branch B, connected having MPLS network, and we have head office, and head office having the connectivity with the internet. So what happened here is, in here every branch was connected through the MPLS provider. Okay, internet access was usually available on the head office. This is the head office, and internet connection are available at the head office. All branch internet traffic first traveled to the headquarters and then went to the internet. That was the problem. Okay, this is called backhauling. Let's say there is a branch user and it's connected with MPLS networks, and then traffic will goes to the head office and then to the internet, and then traffic will goes to the Office 365 if the user in branch wants to connect with the Office 365. In those scenarios, your traffic must be passed through the head office. Okay, that was the problem. Even if Microsoft 365 servers were close to the branch, traffic still had to travel to the headquarters first. That was the issue. That was the problem. Okay, now understand some more problems what having with the traditional WANs. So traditional WANs mostly they were using the MPLS. So MPLS is very much expensive guys. MPLS provides good reliability, but costs much more than broadband internet. Okay, for example, MPLS provides 100 Mbps. It is very expensive. Fiber internet provide 1 Gbps, much cheaper. Companies were paying more while getting less bandwidth. As you see here, guys, you notice the change, right? Now, second problem was poor cloud performance. What's the meaning of that? Years before, most applications were hosted inside the company's data center. Companies have a data centers, and there they hosted their own applications. Like they have file servers, they have email servers. So how the pattern look like in those scenarios? You have a branch, you have MPLS, and then data center. You will connect it to the server which are hosted to the data center through the MPLS. Okay, there is a no problem. But nowadays, what happens is everything moving towards the cloud. So what if you have some clouds like Microsoft, Salesforce, AWS, Azure, Google Cloud? So traffic pattern becomes like branch, MPLS. Now again, your traffic should pass through the head office because head office only have the internet, right? Then reach to the cloud. So there is a one, this extra path increases the latency, right? Because traffic needs to pass from the head office. So that increases the latency. And other problem is single link. Many branches only had one MPLS circuit. If MPLS failed, the branch could lose connectivity until the service was restored. So that is a problem. After the no intelligent routing, what was happened? Traditional routers mainly made forwarding decisions based on the routing tables. They have the routing tables like destination in 8.8.8, that is a Google server's IP, and routing table said they have the default route through the MPLS. So the router forwards traffic over MPLS because that's what the router says. It does not consider the current latency, packet loss, jitter, application type. It does not calculate anything. It does not calculate anything. Every traffic should pass through the MPLS, whether it is a video traffic, audio traffic, voice traffic, whatever it is, it will pass through the MPLS. So that was the issue. There is a no intelligent routing. Coming up to the last problem, there is a biggest problem was manual configuration. Let's suppose if a company had 500 branches, 500 routers, an administrator often had to configure each router individually or use the script. Even if you use the script, same script should run on all the routers, right? That was time consuming and error prone. Error prone means chances of having errors are more because you're configuring 500 routers, 500 branches. So maybe possible you can do some mistakes, right? So that was all the problems. But after that, what happened? SD-WAN come into the picture. Instead of using only MPLS, because traditional WANs relies heavily on the MPLS. SD-WAN, what SD-WAN is? As SD-WAN can use MPLS also, broadband internet also, fiber also, LTE, 5G also, and satellite all at the same time. That is the beauty of SD-WAN. Let's example, you have MPLS, SD-WAN router, internet fiber, LTE fiber. You can use all of them at the same time. The SD-WAN edge measures the health of every connection continuously. It will calculate the health. Accordingly, it will send the traffic. Okay. So why do we need SD-WAN? First is lower cost. Instead of buying only expensive MPLS links, as I told you guys, MPLS links are very expensive, like 100 Mbps MPLS. A company can use 1 Gbps fiber, 300 Mbps broadband, 5G backup, and they will get more bandwidth and lower cost as compared to the only having MPLS. So first was that reason. Second reason, better application performance. Let's say your branch uses Zoom, SAP, YouTube, right? So what will what would happen in traditional WAN? Everything goes through the MPLS, right? But here you can do the application aware routing. What you will do? You told okay, Zoom will use the best latency link. How best latency link will be calculated? I will tell you guys in the later videos. Okay, but it is like application aware routing. You will decide that SAP will use MPLS, YouTube will use broadband, and Zoom will use best latency link. Whatever it will be, it uses that. Okay, so application aware routing it is there. Each application follows a policy that matches its requirements. Accordingly, it will function. Okay. Now, what is the reason 3? Automatic failure. Let's suppose if fiber fails. So, in traditional routers, user lost connectivity. But in case of SD-WAN, what happens? If fiber goes down, traffic automatically switches to MPLS or LTE. Users may not even notice the change. That's the beauty of SD-WAN. Okay. We have cloud optimization also. Instead of sending Microsoft 365 traffic through headquarters, as I told you earlier. Okay. So in traditional, what was happening? Branch, MPLS, headquarters, Internet Office 365. Your traffic will goes to the headquarters, right? In SD-WAN, what will happen? Directly goes to the Office 365. No extra path will be there. No extra latency will be there. Okay. This is called direct internet access and reduces latency. Okay, coming up to the last and very important use case of the SD-WAN is centralized management. Understand, guys. Instead of configuring every router individually, you have thousands of routers, right? So you log into a central controller. For example, Cisco vManage. What is Cisco vManage? I will tell you guys. This is a device, a software. It's used for the centralized management. I will tell you guys in a brief. Don't worry, right? So instead of logging into each CLI, what you can do is you log into a central controller and create a policy once. The controller pushes the configuration to all SD-WAN, SD-WAN. How simple it is. Okay, so these are the advantages we have. Let's understand in a tabular form what traditional WAN provides and what SD-WAN provides. In a traditional WANs, we are using mostly MPLS. Here we are using MPLS, Internet, LTE, 5G, whatever we want, we can use it. Here we have a static routing. It supports SD-WAN support a dynamic path selection like OSPF and BGP. Right. Manual configuration will be needed. Traditional WAN. Here centralized management will be there. Here backhaul to the headquarters. Your traffic should go through the headquarters, then to the internet. Here direct cloud access is there. It's very much expensive. It is more cost effective. Limited application awareness. Here we have concept of application aware routing as I discussed with you guys. Okay, this is here basic failover is there. Here fast automatic failover. Okay, I already told you all those things. Let's I will open one image for you guys whatever we have discussed so far. Okay, so in this video we have discussed why SD-WAN we are using, the problem with the traditional WAN, and how SD-WAN solves it. Okay, before SD-WAN, what was there? Traditional WAN. Traditional WAN, they are using the MPLS. Let's say branch A, they have the head office, firewall, internet. This is the branch B and branch A. Okay, lots of branches are there. So in those scenarios, in case of the MPLS having the expensive MPLS backhaul traffic to the headquarters, poor cloud performance, single link, no failover, manual configuration needed, no application awareness, as I told you guys, right? But after SD-WAN comes into a picture, it's an intelligent and modern WAN. Here, a lot of branches it's there, right? You can configure SD-WAN with MPLS also, internet also, LTE, 5G also, and you can pass that traffic direct to the cloud like a Microsoft 365, AWS, GCP, and Salesforce. What's the benefit of SD-WAN? Lower cost, use multiple links, better application performance with application aware routing, automatic failover, direct internet access, centralized management through vManage. I will tell you guys what is vManage. Application awareness it provides. So the benefit is provide lower cost, better performance, automatic failover, direct cloud access, centralized management, application aware routing. So I hope you guys enjoy this video. So revise this, and in upcoming videos I will tell a lot of things, and you can subscribe the channel also. Thank you guys. Thank you. Bye bye.